just the beginning. AI coding agents offer a glimpse into the future of machine learning workflows.
Now, the reason I want to learn or relearn how to do this AI learning agent type of thing is because I'm trying to make my own Jarvis. I've done failed, twice or three times, and it's been for reasons that I never even thought. Like, I can't put it on the flash drive because it can't read that much files and it's a lot of files. So when me mess up the flash drive, i.e. messing up my computer, if it's not done correctly or if the flash drive just wakes up and say, hey, I don't want to do it and just, you know, second thing I started to realize was when you're making the model, it's easy to make it, but like training it hasn't been something I've been, I guess, well versed in. So now I'm entering the Google Colabs and just Jupyter notebooks, just trying to find something where I could train my model. And that I did it this morning, and that was a learning curve in itself. It was from 5 a.m. to 11 a.m. And that was just something I didn't really expect. Um, because at the end of the day, there's like two different portions that I'm now realizing. There's the portion where you could just take the model and just have it and you're done. You know what I mean? And then there's the other portion of fine tuning the model that you want to use so it could be built on the resources. So I'm still trying to understand how and what direction I want to go
They
in.
are still largely experimental, meaning they have limitations, but they already have the capability to help you automate tasks and speed up production times. In this video, you'll learn how to build your own AI coding agents. We'll use the powerful SmolAgents library from Hugging Face. And I'll show you how to integrate both open source models using Ollama as well as Google's Gemini AI family of models. First, create a new Python environment using Python version 3.12. Then, use pip to install these essential packages: SmolAgents, scikit-learn, stats models, pandas, and NumPy. Next, we need to prepare connections to our large language models. If you want to use Google's Gemini models, you'll need to create a Google AI Studio account and generate an API key. Alternatively, if you want to use locally run models, you can configure a connection to your Ollama server. In the video description below, I've linked to other videos that show how to do setup for both the Google Gemini API and Ollama. I would suggest using Google Gemini over Ollama at the moment for better performance, and the API costs for Gemini 1.5 Flash or Gemini 2.0 Flash Experimental are super cheap.
Another thing, and I guess this is in the comments, I'm realizing a lot of things go with API. I'm a cheap fellow. I'm just saying that now because I'm engulfing and embarking on a journey which seems to be like expensive, but I feel like I'm holding myself back in certain cases. And like other developers could speak for me at this point too. I don't really like spending on APIs because I don't know how it works. That pay as you go model scares me low key because it's like there's no set budget that I could really set. That's how I think immediately. But I'm gonna adopt it. I'm gonna just get comfortable with it. But I just wanted to like just ask maybe a piece mine too. Like, is the API method, although not a method I want to go for, like is it the easiest way to train a model? Because right now I'm not. I don't know if I'm doing it the easiest way. I don't know if I'm doing it the way that the norm is doing it. So I guess I'm just watching videos, making the videos that I'm watching, and trying to get some community help. There's a lot of people that come into my comments and just say that I'm watching another video and just sitting there. No, like there's not another person making reaction videos for content like this, so being the first sucks.
In fact, to prepare this tutorial, which included multiple test runs, the total cost was just a few pennies. Let's create a coding agent. We'll set our coding agent to work on a specific challenge: predicting outcomes using the best combination of features in a linear regression. We'll let our AI agent independently explore, assess, and find top predictors without us dictating a specific approach. Okay, we can now get into the code. We start by importing SmolAgents and OS. From SmolAgents, we'll specifically import a few specialized functions, which I'll explain throughout the code walkthrough. Next, we need to set our Gemini API key. If you are using an Ollama model, you can comment out this line of code. For this example, I'm using Google's Gemini 1.5 Flash model, but you could easily also use the 2.0 Flash
Oh, now thinking about it, the Ollama model
model.
was the only
We
model that
set
I
this using
could
the
get
light
into.
LLM model function's model ID argument. If using a local model through Ollama, swap out this line for a model ID that starts with Ollama, then forward slash, with the model name afterwards. We'll then initialize a code agent called Feature Selection Agent. This specific agent utilizes the DuckDuckGo search tool to look online to find relevant code or reference information if necessary. We authorize it to use several data science packages to perform data analysis and modeling. We also use the model that we placed in an object previously to power the agent's code generation capabilities. With our agent now set up, we define the prompt. I have given several clarifying mission-critical instructions to the agent, such as which specific dataset to load, how to do the train test split, and what the overarching modeling goal and performance evaluation metrics are. Within the bounds of these instructions, I have not told the agent exactly how to reach the objective. Everything else that I have not specified is up to the agent to decide. Finally, to actually run our task, we simply call the run method on our feature selection agent and pass in our task description.
Is he using Copilot?
The agent will now take over, autonomously working towards the goal in the prompt description, and then return its results, which we will see in the output cell. As we will see shortly, we didn't need to write any code ourselves. The agent did everything for us. The execution time of the agent prompt will vary based on the complexity of the instructions, as well as the choice of the model. And the results can greatly vary too, even for different runs of the same model. I highly suggest using proprietary models from Google Gemini, OpenAI, or Anthropic, which give substantially better results. I'd also suggest starting off small when writing prompts and working your way up to larger, more complex instructions. The SmolAgents library can handle multi-agent architectures through the managed agent function, the documentation of which I've linked to in the video description below. If you found this video useful, make sure to like, comment, and subscribe to the
I found it useful. I guess the only thing I can say is we gotta just do this shit, yo. Yeah, I found it useful. Thanks for the content. This has been, I guess, an up and down hill. Useful review. Thank you for the information, brother. Yeah, I guess what I can say is we just got to get into it. Those who come to the live stream, make sure you tune in, grab your laptops, and we'll figure this one out together. Like, comment, and subscribe. I'm gonna be out of here, but I'm also gonna be looking into other videos just on my own downtime. I'm probably not gonna be uploading all of this all at once. If I do, then you guys get the grace of seeing what I go through on the back end. See you in the next one.